Thank you all for coming out today. This is the third part in our series of AWS 101, where we're introducing some of the core services that Amazon provides. So this is meant to be sort of like an introduction. We had EC2, we also had S3, some of the basic stuff in some of our past meetups. And today we're going to focus on RDS, which is Amazon's relational database service. I'm Jeff Thorn. I'm the CEO of Thorn Technologies. Just real quick about us. We are an enterprise software consulting company. We are also an Amazon certified consulting partner. So we've been working with Amazon Web Services for several years. We definitely approach it from a development perspective. We've been building applications for our customers. Almost all of them we host on Amazon Web Services. So we've done some really large scale projects that span several regions to some small, small websites even. So we have a lot of experience across the board with Amazon Web Services. Today we're going to I'm going to give you a brief overview of RDS, like really what is it and why do you care? But I don't want to just stand up here and kind of regurgitate the documentation that Amazon has. So what I plan to do today is really just kind of show you, and we're going to just play with RDS. And I want to demonstrate a few things that are real-world scenarios. These are things that we encounter on a day-to-day basis in our applications that we're maintaining and building for our customers. And so this really, I think, will hopefully give you some insight into really what you can do with RDS, and just a lot more than just reading through the documentation. Now, some of the things that we're going to do, unfortunately, with RDS, it takes a few minutes to start databases and for things to spin up. So I have a couple topics that we can discuss while we're waiting for things. I do want to keep an eye on time too, because there's a lot of information here. So if this starts taking too long, we might kind of go through things a little bit quicker. And so we can end with some just questions and answers. If you guys have anything. So let's dive in. So what is Amazon RDS? So it's the relational database service from Amazon Web Service. When it's fully managed, which means you don't have to worry about hardware, which is what everybody loves about Amazon Web Services. Out of the box, you get automatic backups, you get automatic failure detection, failover, recovery, software patching, security updates. Amazon manages this all for you. And then the nice thing is you don't have to worry about disk failures or database crashes or all that kind of stuff. Does it happen? Yeah, but they design it so you can recover for it and it doesn't impact your application. The nice thing about it too, completely on demand. So like everything else that Amazon provides, you pay for what you use. If you're just doing a quick demonstration like I'm doing today, it'll cost me $1 to show you everything that we're going to do today. If you leave your RDS databases running full-time, it can get pretty expensive, which I'll show you as well. So, but you can start and stop these databases anytime. So it's really convenient for a developer. So real quick, they offer several database types: MySQL, Postgres, Oracle, SQL Server, Aurora. We'll get into a little bit. I'll talk about how that's different than some of them. They have Aurora versions for MySQL and Postgres. They come in different database sizes and instance classes, which give you different computing power. We'll talk briefly about that as well. But for now, let's, really, that's the amount of time I want to spend in PowerPoint. The rest of it, I want to just really kind of dive in and show how things work. So the first thing I want to do is launch a quick database for development. And so just doing a standard RDS database, it's actually very quick and easy. So I'm going to go into my AWS Management Console. Can everybody see that all right here? And I'm going to deal with MySQL today because I've got an application set up that can work with MySQL to kind of demonstrate connecting to and actually using your database. So we're going to start that. So for this use case, we're going to just select a test or development MySQL database. If I start going through these screens too fast, or anybody has any questions, definitely raise your hand or stop me or shout it out. So there's lots to choose from here, and this is where it gets a little bit overwhelming. But for now, like I said, we're starting a development database, so we don't want to worry about a multi-AZ right now. So we're going to say no for that. We're going to do a small database type. We're going to leave it MySQL. We're going to leave it with 5 gigabytes. Most of these are going to be the defaults, but I'm going to do I'm just going to call it RDS Demo 1. And so when you're creating a new database, you give it your main, this is like your root login for your database, essentially. So you don't have access to the server with RDS. So Amazon manages that for you. So they create your root account that you can connect to, and you can create more databases, and you can do all of the things you can do through a client, but you just can't actually log into the server because there really isn't one. So I'm choosing a simple password. Okay, so for network and security, we're going to leave it in the default VPC, and I'm going to get into that in a little bit. Why, what you would do there. I'm also going to make it publicly accessible because it's going to make development easier. When we deploy to production, we're going to change that and make it more secure. So I'll show you that in a few minutes. And for security groups, I'm going to select my existing one, which is just the default security group that comes with my account. And then finally, your main database. I'm just calling demo. And I think that's all we need. So everything else I'm just going to leave disabled. So there's backup options. I'll get into that again in a little bit, but as I mentioned in the intro, Amazon automatically provides backups for your database for you. You can choose here how many days of retention they keep for you automatically. You can manually take database snapshots or backups, and they stay in your account as long as until you delete them.
And it looks like it, but it also automatically configures the actual connections to the database. So if it's MySQL, it automatically populates supports that.
Yes, it does. It knows, right. So 3306 is the default for MySQL, so that's exactly what it gives you as a default. If I want to override that setting right now for any reason, I can change this right here, and then when my application connects to the database, it would need to be on that port that I specified right here.
And it looks like if you have chosen like SQL Server, it would have also put over those default.
Yep, absolutely. All right, so I think we're good. So we're going to go ahead and launch the DB instance. So now this takes a few minutes to create. You'll see it right here. This is my practice one that I did before you guys showed up. Demo 1 is creating. So as soon as that's ready, I'll show you how to connect to it. And then I'll show you how easy it was to have a brand new database that I can just immediately start developing with. So while that's creating, though, I have a few things I just want to talk about. So this is sort of like the network environment that we just created. So your AWS account comes with a default VPC, which is your virtual private cloud. Inside the default VPC, you have a default subnet. And this is really where, if you don't create a new virtual private cloud or a new network or a new subnet, everything that you just launch into your account will end up in this default subnet. As you can see, this M block is the icon for our MySQL database that we just launched. It's connected to the public internet, which for development is fine. But in production environments, it's obviously not what you would want. And we're going to get into that in a few minutes, too, about how to really deploy this for production environments as well. Let's see how we're doing here. We're still creating. So a little bit more on the instance types. Real quickly, I want to talk about that while we're waiting for our database. There's lots of options. If you notice, I chose a T2 small. The different types of options they provide are your standard. Well, your micro instances are usually like the T2 types, and the M1s, which are kind of older generation ones. Those are good for development and testing, but they really don't have the horsepower you would need for a production system. The other options are standard generation. They have varying class sizes, ranging from M4 large up to M4 10X large. And you can see in this chart the different amounts of memory or network performance or virtual CPUs that you get with each of these instance types. Obviously, at a trade-off for the computing power is the cost, and so the RDS database gets pretty expensive as you start scaling up to the 2XL, 4XL, or 10XL. For large transaction systems, you might really, and high performance, you really might need a memory optimized instance where the amount of memory really scales all the way up to 244 gigabytes of memory for huge systems. Again, those get quite expensive. So the T2 finally, the burst capable generation, is actually a pretty good option. Because they have moderate performance, and then they can burst when a capacity is necessary, but you get credits. And so as long as you have burstable credits remaining, you can use more resources than you're actually allocated. If you find yourself using a T2 burstable instance and you're getting really poor performance, it may be because you are using too many of your burstable credits, and it's time for you to increase your instance size. Okay, let's switch over and see how our instance is coming along. You can see now it has the status of backing up. That means it's almost ready to launch. When RDS database instance first starts up, it'll create the instance, and then it'll immediately take a backup copy. That way you have several point-in-time snapshots that you can roll back throughout the day. You could even restore anything as recent as a few minutes ago. Also at night, you can get automated daily snapshots, which are full backups essentially. Here's our endpoint. This is how we connect to the RDS database instance. I'm going to copy this and then put that into my MySQL client and connect to the database to show you how we can actually get started and create some tables. So I'm using a MySQL client for Mac OS called SQL Pro. There's a ton of them out there that you can use, but this is a pretty easy tool to use. So I hit connect. Okay, so the first thing I do is choose my database, and you can see here's the one that I created called RDS Demo when I launched the database. And by default, it does not have any tables yet. Now that we're connected, we can go in and create tables all we want. I can actually add my database settings now to this WordPress setup, and we could show how the WordPress automated setup will go ahead and create the tables and populate the database for us. So I just need to edit the wp-config PHP file, and then update the host name here from my, I had a temp instance that I was using to practice with, but here's the demo 1 instance that we just created. Now if I save this WordPress config, and then when I refresh, it should say it's a brand new installation of WordPress. And here you go. You see the, this is the default setup screens for WordPress. And we can go through this wizard, just hit continue, add a basic site title, and now we have to enter our username and password for WordPress. And then when I hit the install button, it should create all the WordPress tables in our brand new database for us. Okay. All right, it worked. So let's go ahead and log in. And we could use our, well, you can see now here's a working WordPress instance that we just spun up in a second. Now, if we go back to our MySQL client
and do a refresh, we should see all the new tables that the WordPress installation just created, including the sample posts that we just saw. We can go ahead to the database and modify this information directly, just to show you that we are in fact working with a live database. So hit OK. Now if I go back to the web page and hit refresh, you can see the title has changed based on what I just entered into the database. Okay, so going back. So now I'm ready to talk about how to deploy a real production quality database. What we did so far is great for development, but like we said, it's not going to scale. It's only a single instance. It doesn't have any failover or redundancy. So now we can talk about deploying a multi-instance database that has replication across multiple availability zones. This is necessary for production environments. If there's an outage in one availability zone, all the database transactions are replicated between the two instances. So one database can go down, and the second database can immediately pick up as a hot backup. And so now we can show you how to do that. So I can modify our existing database instance, and I can change it from a single AZ deployment to a multi-AZ deployment by choosing yes. Now, just so you know, this does double the cost of your RDS instance, because now instead of a single instance in one AZ, you now have two instances running, one in each AZ. So a multi-AZ deployment is more expensive, but for most production systems, the cost is justified.
So multi-AZ is hugely important for production databases. It gives you that redundancy and that high availability. So that's the big thing that we're going to change. The other thing I want to change is network security. Okay, I don't want it in my default subnet now. So this gets into kind of the VPC topic, which really isn't a topic for today. We can talk about that all day, maybe a future topic. I have a separate private cloud that I've pre-created called RDS demo that, that is not publicly accessible to the internet. It's a private network with private IP addresses. Okay, and so that's where I want my database to live. I don't want my database to have a public IP address. I don't want it exposed to the internet where people can, brute force attack the password or just attack it so that it becomes unresponsive. Everything else, let's see, I think can stay the same. In real production systems, we might want to have enhanced monitoring, which gives you, statistics down to the second versus every couple minutes. And same with maintenance, I'm not going to change, but you do have the option to tell Amazon when it's okay to perform maintenance on your database. They will automatically apply minor version updates to the database software for you. And so they only do that in the maintenance window you specify. All right, so let's go ahead with those changes. So you can see I'm going from no to multi-AZ to yes, and no, yes, publicly accessible to no. And then my subnet group is moving from the default to my private VPC that I have created. I am going to apply these immediately, and away we go. So you can see here under my status, it says now that we're moving to VPC. So that's going to take a few minutes, but I'll show you the difference as soon as we, get back. They are. So there is an event log right here that kind of shows you, I created my DB instance, I started it, I backed it up, I finished. When it's finished modifying, there'll be a new entry here as well. So this is the event log. Amazon also has something called CloudTrail, which until recently you had to enable ahead of time, but now they enable that by default for you, which is really for auditing purposes. And that keeps an audit of every Amazon API call that things are made, whether you make the API call directly yourself or through the console.
Does the multi-region deployment, are any connections allowed?
So talk about that. Exactly, good question. So this is, after we're done modifying our database, this is what our new environment is going to look like. So we have now, instead of the default VPC, we have this demo VPC that I had created. And inside of that are several different subnets. So there's a private subnet in availability zone A. There's another private subnet in availability zone B. Now those have private IP addresses, so those databases are not connected to the internet. So I'm going to show you in a second how you connect to those. Right now, and then there's a third subnet here that's a public subnet, which is where our public, our web server, our WordPress web server resides. Even this is not the most ideal network environment. Ideally, your web server would be in a private subnet too, and then you would front that with a load balancer. And what that does is gives you the smallest attack surface possible, so people really from the internet couldn't even get to your web server. I just wanted to mention that. But for today, we've got the web server with a public IP address, and we're going to use that to tunnel into our database. So let's see, we're still going. So while this is going, I kind of have a couple other things to talk about. One of them is cost. I kind of mentioned that earlier in the topic that RDS can be expensive. And for all of the applications that we build, I'd say that RDS is probably half the bill is RDS databases. Now there's ways to mitigate that pricing. But what I want to show you today is this pricing website, this doesn't tell you much. I mean, it tells you, you can see that a R3 2XL is, almost $1 an hour, which that adds up quickly. But you really don't get a feel for what's that like at the end of the month when you get your bill. So what I have to show you is actually a copy of one of our recent bills, so I can really break down what these charges look like. And you can see, RDS is not cheap. So, we've got a number of instances running here. So storage, you can see the first thing is gigabytes per month. We've got some of them are 4 of them are multi-AZ. The thing with multi-AZ databases, you got to keep in mind, is that you're paying for each instance. So it's twice the cost as a single AZ. We've got some small ones for some smaller projects, but most of them are large or extra large. What really stands out here is the storage that we're paying for. Now, we've got big databases. One of these is a data warehouse that's got data going back 6, 7, 8 years even. The other one is a large transactional, messaging database where we do a large volume of messaging, 5 million messages a day. So RDS will charge you for the storage that you provision. So we're spending $1,000 a month on just the storage that we've allocated to our databases. There is ways to bring this cost down significantly. So, and we can do that with what's called reserve instances. So with reserve instances, you prepay your hosting of your database.
So if you know that you're going to have a database that runs full-time for a whole year, absolutely it makes sense to buy a reserved instance because it is a significant savings in cost. The trade-off for that is that you have to pay up front for it. So there's 3 different options for paying up front for it. First of all, you can choose a term of 1 year or 3 years. The longer the term, the deeper the discount. You can do no upfront payment, which gives you a reduced cost. You don't have to pay up front, but you are going to be charged for it for the entire year, whether you use it or not. So again, you don't have to pay up front, but you're still going to be billed for it for the entire month, every month. You can do partial payments, which gives you a very reduced hourly cost for an average upfront payment. Or you do a full upfront payment, where you have a 0 hourly cost, but your upfront payment, depending on the size of your database, could be expensive. It could be several thousands of dollars. Now, in this case here, we ended up paying $1,200 up front for the entire year. And so the normal on-demand pricing is 95 cents an hour. It brought it down to 18 cents an hour. So you can see down here, if you do the math, and on demand for the entire year would be about over $8,000. We've brought down to under $3,000. So it is a huge discount in pricing. Question?
So the previous slide had MySQL as your database. This one has Aurora.
Yes, I'll get into Aurora in a minute as well. Aurora is another option. It's basically Amazon's proprietary database that is compatible with MySQL or Postgres. And we'll talk about that in just a few minutes.
So that had no influence on the pricing, though?
Aurora actually is a little bit more expensive than MySQL, but you get a lot more out of it. So I'll kind of compare some of those things in just a few minutes. So Aurora is actually more expensive, but because it was a reserved instance, it was still way cheaper. Okay?
I have a question.
Mm-hmm.
In case in the reserved resources, after some time you feel like, no, this is not sufficient resource. I don't have sufficient resources.
Mm-hmm.
If I want to upgrade to more resources,
Yes.
how the price will be?
How the pricing, so they will bill you out, so for reserve instance specifically, that's a good question, because until recently, you were kind of locked into the reserved instance that you purchased. So if you purchase a reserve instance for small, and then you realize that you need a medium-sized database instance, it's not going to convert. You're going to end up paying the full on-demand price for the medium instance. Now, recently, Amazon did, only within the last month or so, or a couple months, they do, I think, have an option to let you resize your reserved instances. I don't know the full details on that. I've never had to do it, but you can do it now, I believe. What you used to have to do is, there's a marketplace where you can actually resell your previously purchased reserved instance. So, if I had to upgrade to a medium database, I no longer have a need for that small that I purchased. I can actually go ahead and resell it on the Amazon Marketplace, and someone can buy that from me, and then get it at a reduced cost.
Jeff, are there spot instances available for RDS like EC2?
Yeah. Actually, that's a good question. No, I don't believe there is actually.
Okay.
No, but no, actually there isn't. Okay. But another thing that they just announced recently, which is a new feature too, until recently you were not able to easily start and stop databases. You had to literally shut down your entire instance and then recreate it and then restore it from a backup if you wanted to bring it back up again. That's new also. If it's a single instance only, you can actually just stop it the same way you do an EC2 instance. Now, stopping it is different than destroying it. It's just, it kind of stays in your account, but it's just not running, and you don't get billed for it. So that's a great thing for developers now. That is new.
And schedule that.
Yeah, yes, absolutely. So you can even have like a script that runs at the end of the day. If anybody left a development database running, you could just stop them.
Right.
So, okay, yes.
Is that true for all of them?
Sorry.
So there's like 5 different databases you can instantiate, and I guess the premise is that these are all service endpoints versus the database running on a VM instance.
Right.
So they're all service endpoints, and I
Yes.
guess one of the things with Oracle and I guess MySQL would be licensing costs in addition to the
Yeah.
capacity and throughput
Right.
of those.
Right.
So can you do that with any of them?
Yeah, absolutely.
Like
Yes.
stop and start them, you don't have to do that shut down, restore, backup, restore, blah, 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 every time you want to do that on and off cycle.
I believe so. Again,
Okay.
that's a kind of a new feature, the ability to start and stop. So I've never had the opportunity to try it on like a SQL server
Okay.
or anything
I'm not
like
going to
that.
put you on the spot. I was
No,
just-
that's fine. I believe you can though. But the important thing is that you can only, for any of them, you can only do it when it's a single AZ database, because otherwise, if you stop it, the replication is going to get all out of sync, and then the whole replication infrastructure just no longer works. Okay, so how are we doing on our? Okay, now it's modifying. We can move on. I don't necessarily need to show you it running. The only thing I was going to mention is that like our database now should have a private IP address, and we'll see if it's available even. Let's see what happens if I'm going to cut. Here's the host name that the host name will stay the same even though it's been modified in our network.
This is route 53.
Yeah, so you can see it's already done. So this is now the new IP address of the database that we created, right? And so this is a private IP address of one of my subnets that I created in the VPC. So that means, what does that mean though? That means that we can't really connect to it anymore. So if I try to, refresh, it's going to time out. It's just going to, we're locked. So how do you connect to your database then, is the question, right? So our connection is lost. So one technique is, and most SQL or database clients support the ability to tunnel, SSH tunnel. So what I'm going to do is, I have this set up here now. So what this means, the way this sets up is that I want to connect to this host name, RDS demo 1, which has a private IP address. So from here in this office, there's really no way I can get it, unless I tunnel through SSH through this server. So I'm going to log in as the EC2 user using the key that Amazon gave me when I launched the server. And now by tunneling through the web server, I can then connect to the database. So let's see if it's ready for me to do that. There we go. So now here's our database. And again, I'm connected to it. And we should be able to make some changes. Everything is hunky-dory, even though this is now, I'm just manipulating the data in a database that's a private database. So let's see. Yeah, there you go. So it worked. So that's how you kind of modify your database and design it for your production environment. So another cool thing about RDS is they provide backups for you all automatically. We talked about that. You can choose how many days worth of backups they keep on your behalf. By default, it's 7 days. That means that at any time, I can just go in there and restore a copy of my database from 7 days ago. I could also go in there and manually take a backup of the database, and then that will stay in my account forever. So what we do in a lot of our applications is at the end of every year, we'll go ahead and take a manual snapshot, and then if we want to wipe out data for the next year, kind of trim down or do some database maintenance to keep our tables smaller, we can do that. We can always restore the backup that we made of the previous year if we need to get that data back. They also do point-in-time restores, which is really cool. So I can do something awful like delete star from WP posts
before I do that, let me just make sure. Yeah, it may not be, I may not have given it enough time to actually take a point in time backup. So if I go here, I can go to this restore point in time, and it's going to tell me that the last restorable time is at 7 p.m. Yeah, so that was only 7 minutes ago. So if I go in here and do something like this, delete from WP posts, okay, I don't have any more content, do I? That's what happens. Yeah, that's gone. See, our blog is going to look pretty awful. Nothing found. But, you know, that's usually a pretty awful thing. You just lost all your data. So I could go into the console here and then say I want to restore back to 7 p.m., which was, 7 minutes ago. Let's just go ahead and I've got to give it a different name. So let's call it like backup. Let's call it back. Okay. So now you can see that it is now restoring my backup copy. And so that'll take a second, but then you should see our lovely posts will be back as soon as we come back to this. So that's really great.
Well,
Sorry.
you're creating another instance, aren't you?
I am, and I
you'll
did
have
that.
to copy it over.
I did do that only for an interest of time.
Oh, sure. Okay.
It could take over 20 minutes if I want to. I would normally rename my current database that I just wiped out and then recreate the backup with the original name, and that way all my applications would just keep working. But it's already after 7 o'clock.
Yeah, sorry. No, just
We're running short on time. That's all right. So while that's going, let's see, what else do we have to talk about? All right, so just some things I want to point out that over the years we've kind of experienced and learned. A lot of this is all buried deep in the documentation, but sometimes you just have to use it to learn some of this stuff. Keeping an eye on your database metrics is important. One of the most important things to keep an eye out is the amount of RAM, like memory you're using. Databases are designed to do almost all of their work in memory. So if you don't provision enough memory for the instance, it's going to have to swap to the disk a lot. You're going to get a lot of read IOPS, which means it's reading from files on the server. And that's going to really slow down your database, like significantly. Your query is going to take forever to run. So it's easy enough. In fact, Amazon used to give you a little, like, see these little red lines? Like, these are kind of like little warning side. When your CPU is getting a little too high or your memory usage is getting a little high, they kind of is a good, let's see, so, yeah, so all these statistics are here for you to look at. But the real thing that's important to keep out is just make sure, you don't know if you have enough RAM, but if you can keep an eye on your read IOPS, as long as that's small and stable and consistent, it doesn't change much, it means the database is working the way that it should. If you see it spike and jump, it means that the database is not optimized for its memory and it's reading from the disk a lot, and that's not what you want. So it's time to increase your size. Don't run out of disk storage. That happens. It happened just a week or so ago. It was, I think, actually. So, but the nice thing about it is it's just managed for you, right? So it was really it was not a disaster at all. Our application started getting errors, just like you would if the hard disk was full. So in our Java log files, we were getting JDBC exceptions that just said no space left on disk or whatever. And so all we had to do was go into the console, modify. So we just, we would just go into modify, we would change our allocated storage from 5 gigabytes. Well, we actually added another 500 gigabytes in this one case. And in less than like 5 minutes, our application was working fine. And so, you know, as long as you design your applications to be able to recover, you know, in our case, we had data queued up that we were able to just replay. Everything, you know, was recovered from very smoothly.
So storage cannot be auto-scaled?
No, that's a good question.
CBS.
Regardless of the DB?
No. So the nice thing about Amazon is there's APIs for everything. So when you say, can it be auto-scaled? Well, yes, you can technically trigger a CloudWatch alarm on the free storage available, and then if it gets a certain threshold, you can have it run a Lambda or some other type of job that then makes an API call to increase the allocated storage. So you can actually do this all yourself. But there isn't like the notion of auto-scale groups like you have with EC2 that automatically, you know, does it for you. But it actually would be pretty easy to do yourself if you wanted to. So what else? So backups. So it does, you know, that you do have a maintenance window and a backup window, right? And those are the things that we specified when we were creating our database. Well, it's really important to make sure those are happening at realistic times. You know, so for 2 of our clients, one of our clients, we run that big data warehouse. We run a lot of ETL and load jobs in the middle of the night, where that's the only time we're writing to the database, really. And so it doesn't make sense to be running our backups at that time or to be applying software updates, because that's really when we need the database to be, you know, write intensive. We also have another application that's deployed in Asia, you know, and so you got to be really careful there, because when the maintenance window is in the middle of the night, that's the middle of their busiest day. So, you know, those are things we've learned the hard way. We want to make sure that backups are happening at the right time. So another thing that this happened yesterday, we did experience a failover in our availability zone. We didn't experience any outages at all, but you know, we noticed that we had a momentary delay, if you will. It was less than 30 seconds, and everything picked up and was fine. Curious why that was, I've noticed the IP address of our database changed. That's because it failed over to a different availability zone. So if your application is caching DNS, that will not work for you. So that's very important to not cache your DNS, because then when it does fail over, I mean, you have to give your application the DNS name of the endpoint. So that way Amazon can control what IP address it points to for you. And finally, you know, you don't want to expose it to the public internet for, you know, obvious reasons. You just don't want people snooping around where they shouldn't be. What else? Let's see. So here are some of the monitoring statistics that I kind of showed you. There's a lot. There's actually like 8 pages of statistics that you can really, real quickly. You know, CPU is the important one. If you're running a lot of queries that are taking a long time, and you can see your CPU is maxing out at 100%, it's time to increase the size of your database. Same with memory. You know, if really you don't know. You really don't know how much database or memory your database should use, but again, that read ops is a good clue, IOPS, as I mentioned. And then, you know, database connections. It's always a good thing to keep up. You want to know how many. Sometimes you lose track of how many applications you have out there that are using your database. And if it gets too high, then you might run out depending on how your database is configured. Okay, so the last thing I want to touch on is kind of like replicating our database, and this kind of bleeds into disaster recovery. So what happens when, you know, we're now in production, we've got a lot of users, everything's going well, our database is getting a pretty consistent volume of transactions, and it's busy, just actually completing transactions. You don't want to start doing analytics on that database. You don't want to run long report queries that might take 20 minutes to run and lock tables or just slow everything down, because that's going to affect your actual transactions. So what you do is create a read replica. And that also is very easy to do in the dashboard. So using our RDS demo 1, I'm going to do, let's see, I'm going to create a read replica. So the important thing to point out here is, where do you want this replica to live? And so what, for anyone who's not familiar, what a read replica does is you have a master database which is handling all of your reads and your writes. And so you're writing database to the database. You then have a slave copy of a database which is meant for just reading the data from only. But what it's doing is it's taking the transaction log from the database and reproducing every single transaction that happened on the master on the slave. And it does it very, very quickly. So really, one of the things you look at with a replicated database is called your replication lag, which it'll show you how far behind the master the replica is. And if you had an outage and you had to fail over to the replica, only things that happen in that lag period are things that you would risk losing. So, but usually it's very, very low, so you're usually in good shape. So in this case, I'm going to go ahead and try and create a replica in Oregon. So this is a different region. So let's see, do I have, I'm going to, for now, I'm just going to make it in the default. And so we're going to call this RDS demo 1 slave, okay? And make sure I don't have that already though. No, I don't. And everything else, we're going to do the same. So we'll go ahead and create our read replica. Okay, so this is just telling you that we've gone ahead and done this. This is cross-region replication, which might take a little while. For our simple case here, this should be done in just a few minutes. But in a large database like the one I showed you earlier that had 3.5 terabytes of data, that might take all night long before it replicates fully across another region. So let's see. So this is our RDS console in Ohio. I have Oregon up here. You can see now it's in the process of creating our new slave database. So let's see what that looks like. So this is what our new network environment looks like. So we've got our original VPC with our load balanced master databases. We've now created a second instance in this in the West 2 region, which is Oregon, and this dotted line represents it's a replicated source. So everything that happens on this database will happen in this one. And so going back to my original use case, once this is up, if I want to do really long analytic queries, I can pound this database all I want. I can generate reports and run queries that take half hour to run. It's not going to affect my master databases, and it's not going to affect the performance from the perspective of our users either, and that's what you want. So what else you can do, that's still going to be creating. So let's move on.
Jeff, you can promote that read replica if needed, right?
It's exactly where I'm going next, yes. So this becomes a critical part of your disaster recovery plan, too. So with a read replica in another region, in fact, this is my last scenario here. Holy exclamation, the entire region went out, which doesn't happen often, but it very well could. All the stuff I've been demoing tonight is in the East 2 region, which is Ohio. If for some reason there was a critical outage there, if you don't have this cross-region replication, you're going to have an outage too. But if we now have our database replicated to another region, in no time we can promote that read replica to become a new master, and then we can be back up and running in another region in like no time with little to no data loss. So let's show how to do that. So let's see, do I have any? So yes, so because this takes a while to create, I have a slave pre-created here. You can see that here I'm in Oregon, and I can go ahead and go into this slave replica, and I can just go here to promote read replica. That's it. There aren't too many options to choose. I'm just taking this slave copy and now making it the new master. So I do want backups. I don't have a preference for the window. So I'm going to go ahead and do that. So now in Oregon, you can see that this is becoming the new master. And so what I have here to show you too is I have another EC2 instance running in Oregon. That the EC2 instance is just a web server. You know, it's got the same installation of MySQL. Now, in the real world, yes, the web server would have images and assets and things that you really can't fail over as easily as I'm showing you. You know, the real way to do that is to push the assets up to S3, which we have a product actually that's going out in the marketplace that does that soon for you automatically. So yeah, one of our products that we're getting ready to launch into the AWS marketplace is a high availability, scalable WordPress instance that offloads all the images and assets to S3 and CloudFront, so that you can just fail over like this very easily, because the images and the assets are not stored locally on the web server instance. It does a lot of other great things too. Like it actually creates this entire, this whole architecture for you as well too, so your database is properly deployed in a production environment. So in Oregon, I can go ahead and modify our database settings. Oops, not the right one. Yeah. So we're going to change it to our slave. So this might be set up already to talk to my sample. So the slave 2 is rebooting. I mean, we can give it a second if we want and see how long it takes. All right, it's ready to go. Once it's backing up, you can still connect to it. So let's do that. Slave 2. Whoop. Hold on, bear with me here. I did not set the permissions properly in Oregon, but so now with a little bit of DNS work, or for the sake of this documentation, modifying my Etsy host file, I can repoint my DNS name to Oregon instead of Ohio, and then everything is completely failed over. So if I change the IP address of our web server, and normally you would do this in DNS server, obviously, but for the sake of demo, here we are. So this is my old slave that I had running in Oregon, but you can basically see that's how quickly we basically failed over from Ohio to Oregon. So that's how, using a read replica, you could promote a replica to a master, repoint your DNS, and then now in the event of a regional outage, you're back up. So let's see. Question?
So, given my background, there's like a log file that has all the transactions,
Mm-hmm.
and conceptually they're still in queue and being applied to the database.
Right.
So when this happens, is that queue being replicated as well? So I know there's a small interview that you're saying is back,
Right.
but when you're saying it flips over, then this one assumes a whole new transactional queue against the database. I don't know that MySQL is particularly that architected that way, but I assume
Right.
there's a general implementation of that.
Yeah. I mean, I think that's standard database kind
Okay.
of transaction. You know, I think they're all kind of based on that concept. So I said little to no data loss. I mean, yes, there's possibility depending on how frequent your transactions are and how busy your database is. When there's a failover, you might get, you know, some data loss, and you're going to have a little bit of downtime.
But I guess behind the scenes, when you press the icon for replicate,
Yeah.
it behind the scenes does some code that looks at this database this way and purely reconfigures it that way. And just for as it's known to be a replica,
Yeah.
it's just taking that log file, shipping it, and applying
Yep.
it
Right.
until you say like, oh, this is active. Now the transactions are coming in. It's based upon the thing and doesn't know any better and otherwise.
Right. Well,
Okay.
what's going to happen is, you know, the first thing that it's going to do is going to take your current master and then stop, you know, accepting transactions.
Right.
So you're not going to get any new transactions as soon as I hit that promote, you know? So that's the time that our applications will probably like fail for a little bit,
Right.
you know? And then the transaction, you know, it will then promote the replica now to a master and then swap the DNS, you know, and then now if our applications reconnect, it should, well, yeah, depending on the host name, it should just pick right up. And so,
Okay.
yeah. So the last thing I really want to talk about real quick, any other questions before we move on?
When the replica is in different region and your private network is different, right? Because your VPC is located in one region
Mm-hmm.
and you have replicated in different region, how the network communication happens?
Good question. So for the sake, so I had two web servers, kind of with the same network environment. So this kind of environment existed in Ohio and in Oregon. So this web server in Ohio can talk to this subnet in Ohio. This web server in Oregon can talk to that subnet in Oregon. So what I did is I copied the database into this subnet in Oregon from this subnet in Ohio. So that is something I did set up the subnets ahead of time. So you know that's a whole nother. The whole VPC is a topic for another meetup discussion, and I think it's one that it might be worth looking into. Part two, yeah. Oh yeah, we did, right.
CloudFormation.
Yeah, exactly. Well, CloudFormation is another one I think we're going to do too. In fact, we do have a CloudFormation template that does this image right here. It will kind of launch your database into, I don't know, it doesn't do the replica, but we have a CloudFormation template that we can make available on the meetup page or wherever. That will set up your VPCs for you with multiple AZs, deploy your database into the private subnets, and set up all those network rules for you.
So that should be that should be a different VPC under
Yes.
AWS account.
It is,
Okay.
entirely, yeah. So what I should have done is created a final version of this that actually showed these two things side by side, one in Ohio and one in Oregon. So that's how it would have looked. Yeah. So real quickly, we talked about Aurora, which is a new product relatively new product from Amazon. It is their drop-in replacement for MySQL and Postgres. And so what does that mean? It means it's not the code base of MySQL or the code base of Postgres. It is their own proprietary database. However, all of the APIs and the commands and the network layer is exactly the same. So you can use a MySQL driver to talk to an Aurora MySQL instance. You can use a Postgres driver to talk to an Aurora Postgres instance. It's not the real thing, but it's 100% compatible. But it does things the Amazon way. So what they've done here is really replicated your data in clusters and storing it in these high availability solid state drives. They've really optimized the way that the data is stored. And they automatically provide this availability and failover for you. I'd say one of the nice things, well, there's a couple of nice things about Aurora. Number one, you do not have to pre-allocate your provision storage. That was one of the main things that we had to do when we were creating our database instances. I had to say, give me a 5 gigabyte database. Oh no, I ran out of storage. I need to now modify my database to add 500 gigabytes. We went through all that before. You don't need to do that with Aurora. It does it automatically for you. So that's really nice. You only pay for the actual storage that you're using instead of what you've allocated. So that's a big plus. Also, the way that they store the data, that replicas are promoted to masters way quicker. So, it's probably still going, some of these stuff that we were doing. Yeah, I mean, see, it's some of the slave stuff that we created, our demo is still going, which is why I had a second copy for demo purposes. But with Aurora, that happens much faster, and so it's actually can be part of your maintenance process. You can, manually fail over to one database, apply an update, or do some kind of long-running table manipulation, and then fail back, and then let it replicate across. And so with Aurora, you can do those kind of tasks much easier. And according to Amazon, it's up to 5 times faster than traditional MySQL. And all that for a very, very minor change in price. So, Aurora for an R3 extra large on demand is 58 cents an hour versus 47.5 cents an hour for MySQL RDS. So really, the benefits that you're getting really outweigh the cost difference, versus traditional RDS. So really, I think this is really the future kind of where Amazon is going with their database products. They want you on theirs instead of the commercial, or they're probably not going to have it for Oracle or SQL Server, but certainly the open source databases like MySQL and Postgres. These are highly performing, and they're an alternative that gives you that high availability. So that's it really. Any questions? Anything? Any final questions or anything?
On overall, I think I'm always in a confusion that when you compare the on-premise to cloud, on-premise the infrastructure you buy one time.
Right.
It's a one-time cost, but it is as long as you go, you have to keep paying.
Right.
So all the time, are we not paying more than on the on-premise?
For Aurora?
No, not
For
overall.
RDS. Yeah.
RDS or Amazon Web Cloud architecture.
Depends on the use case.
Yeah.
I mean, it's overall when you buy infrastructure from Amazon, any cloud providers.
Well, so for Oracle or like SQL Server, they build the licensing cost into the hourly fee. So let's see if we have that handy.
You can also bring your own licenses.
Yeah, you can bring your own licenses, or you can pay hourly for, so Oracle or SQL Server per hour is going to be very expensive, unless you bring your own license, which you've already paid for.
There's calculators out there that
Yeah.
help you with that. So,
Yeah.
depends on the use case. Yeah.
So So once again, you can find us on thorntech.com is our website. We also have a YouTube channel that has all of these meetups. So if you're interested, you can find some of our past meetups. Pretty soon we can find this one there too. We'll have that up as soon as possible. And you can follow us on Twitter at thorntech as well. So thank you guys for coming.
Thank you.
Thank you.